Okay, so as I was saying, Mike breaks apart a shape into two smaller shapes. Rick breaks the same shape apart into two different shapes. Explain how you know that the total area of Mike's two shapes is the same as the total area of Rick's two shapes. So if Mike breaks his into two smaller ones, Rick breaks the same shape into two different shapes. So it's not going to change the area because it's the exact same shape that they're both using. That was what I was continuing to say. Okay, we are going to move down to try it. Use what you just learned about adding areas to solve these problems. Show your work on a separate sheet of paper. So if you have a piece of paper, feel free to pull it out and write on it, or a whiteboard, anything that you have, go ahead and get that out. Okay, so I did number 12 because I wanted to try it before I taught it to you guys, so I knew what I was doing. So number 12 says, what is the total area of the shape below? It says there are 14, 10, 9, this side is 6, this side is 5, and this side is 4. So it wants us to break it apart. So this is what I'm going to do. I'm actually going to download it and I'm going to show you better so I can draw a line on it. Let me just scroll down and find it real quick. Okay, right here. So if I want to create a little line right here, I'm going to show you maybe well, I thought I could draw on it, but maybe it's not going to let me. That's okay. So I'm going to show you right here anyway. So if I draw a line right here, and I kind of did it on my paper. So if you look, I did it. I drew a little dotted line right there. So I did it that way so I could break it apart and show you how to break it apart. So if we break it apart right here, I put on mine that I know that this side is 4 right here, and I know that this side is 5. So we know already what 4 times 5 equals. So we know that that is 20. So you can see where I got it, 20. Then on the bottom part, you have already this part highlighted right down here, which is 9, and you have your side highlighted, which is 10. So then you only need to worry about this square right here. I can show you, I'm going to try to show you where I'm breaking it apart. Right there. Perfect. So I got the pen to work. It's okay, technical difficulties, we all have them. All right, back to this. So I divided it. Now we know that this number here, we already said what it was. So let's find it and use it. So we said 4 times 5, which is 20. And we know that 10 times 9 is 90. Good. So in that, we have 90 and we have 20. Now I need to figure out how to get those two shapes together so we can add them to get the total area. So if you saw me up above, you know that you have to add them. So 90 plus 20 equals what? Well, it equals 110. Don't forget your square meters. Good, 110 square meters. Okay, now number 13. I did not do on my paper because I wanted to show you how to do it on my paper or on my whiteboard, doesn't matter what. So I'm going to actually make my screen to show me just me. Okay, so you can see it a little bit better. Okay, now we're working on this one right here. So I'm going to look at this and I'm going to decide how I need to separate it. So if you look at it, get it centered here. If you look at it, we know that 7 is one side. We know 5 is one side, we know 8 is one side, we know 3, we know 1, and we know 2. So now we need to figure out how to break that apart. So if I wanted to break apart a shape into 2 rectangles, I need to figure out how to do this. So let's look. I know that I could do a cross. If I wanted to do a cross, I could do a cross. So I can show you how to do that. I wanted to. Okay. So I drew it across. Now, do we really need to worry about this 1 centimeter now? I don't think we do. So we can actually just ignore that 1 centimeter. But look what we do have. We have an 8 and we have a 3 already in this bottom rectangle right here. So can we do 8 times 3 to find the area of that rectangle? We can. So I'm going to write right inside of it. 8 times 3 equals 24 centimeters. Oh, square centimeters. I'm going to make sure that's square. Then, now we need to figure out our top. We need to figure out the top. How can I do that? How can I do that? Well, let's look at our numbers. So we know our top is 7. Does it give us a side? Hi, I'm back. Sorry, it cut out again. I'm not really sure why, but that's okay. Technical difficulties, we're getting through it. Anyway, as I was saying, do we know if there is a side? We cut it in half, and I'll remind you how we did it. So I want to show you in a big screen so you can see it better. So I kind of cut it in half a little bit, and we said that 8 times 3 is 24, and now we need to find our 7 times, what is our side? There's a 2. 7 times 2 equals 14. So now we need to do something with our 14 square centimeters and our 24 square centimeters. So what are we going to do with those 2 shapes? We are going to add their areas together. So it's going to be 24 plus 14, and it equals 38 square centimeters. Just like that. Nice job. All right, that is our introduction to the area problems with rectangles that are not the correct shape. So tomorrow's video will be a little bit more on complicated shapes, kind of like this. And we'll get into those a little bit, and you'll be able to add them together and find the areas of those kinds of shapes as well. But I wanted to give you guys an introduction video first. I didn't want to just make you guys do it and not know what you were doing. So check out the assessment. Also, if you would like to check out your practice problem, it is lesson 29, I believe, in your practice ready books, which is your homework books. It is lesson 29, and it is on page 315, and it looks a little bit like this, just for your reference. And yeah, go ahead and take the assessment on part 1 and part 2. Make sure you get that in, and I'm going to extend this lesson a day into tomorrow so you guys have a little bit more practice on it. All right, good luck. Bye guys, miss you. Good afternoon, 3rd grade. It's Miss Barker. Hope you guys are having a great evening. We are going to jump right into lesson 29, part 2, where we are learning about finding area of non-rectangular shapes. So it looks a little bit different from one we had yesterday. Yesterday's was all about rectangles in their shape, and this one's a little bit different. You can look at it, they're not rectangular shape. So we're going to talk a little bit about that. So first, we know that we need to read the problems, and we need to explore different ways that we can find the areas of the shapes that are not rectangles. So in our first one, Elsa used 1-inch square tiles to build the shape shown at the right. What is the area of Elsa's shape? So we kind of went back to what we were talking about when we were doing the 1 square inch blocks. So you can see that they've put 1-inch square blocks in. Now I'm just going to count them quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square inches. So what is the area of Elsa's shape? It is 10 square inches. Just like that. Now, our second one says picture. It says you can find the area of a shape by counting the number of square units that cover the shape, just like we just did. If you want to look at it, we just did it. This way. There's 10. We did 10. So there are 10 square inches. So now we're going to look down at model it. It says you can find the area of a shape by breaking it apart into smaller shapes. So if we look at this one over here, it says the area of this is 8. The area of this is 2 square inches. Then they broke it apart. So they did 1, 2, 3, 4, 5, 6. So they broke this into 6, and then they took the last 2 down here and put it next to these 2 to make the 4. That's all they did. It's the same type of area. They're just breaking it apart a little bit more. So then, now we're going to move on to our connecting. So we're going to connect it and we're going to solve the problem from the previous page. So now it says, number 9, model it. It says shows 2 ways to break apart Elsa's shape. Look at the first way. For each smaller shape, write a multiplication equation to show its area. So we need to write a multiplication problem to show its area. That means that we are going to fill in what this one is and what this one is. That means that we are going to do 4 times 2, which equals 8. So if you look, there's 1, 2, 3, 4, and then we have 2 across. So that means that's 8. So let's fill that in. 4 times 2 equals 8. Fill that in. Then our other multiplication column is 1, 2 times only 1 across. Oops. So let's try that again. Sorry. 1, 2, and then only 1 across. So our width is 1 and our height is 2. So then we're going to fill that one in with 2 times 1 equals 2. Just like that. Now we need to add our areas because we need to find the whole shape of this, the whole thing. We need to find the whole thing. So now we're going to add those together. So we're going to put 8, because that's the area of the first box, and then 2. So 8 plus 2 equals 10. And then it asks what our square inches are, and they are 10. We got the same answer there as we did here to find it. Now we're going to look at the second way to break apart Elsa's shape. For each smaller shape, write a multiplication equation to show its area. So now we need to look at our shape again. And now we're looking at this one. So we have to look at how many across. There's 1, 2, 3. How many down? 1, 2. So we know that we have to do 3 times 2. And it equals 6. Then we need to do the next box, which is 1, 2 by 1, 2. So you're doing 2 times 2. And 2 times 2 equals 4. Nice job. Now we need to add something. What do we add? Well, we have to add the 6 and we have to add the 4 because 6 is our area of this one and 4 is our area of this one. So now we have to add 6 plus 4 and that equals 10. 10 square inches. Did we get the exact same answer? We sure did. Now it wants to know, it says, how does this total area compare to the total area you found in problem 9? So it wants to know how it's the same. So let's take a look. I'll show you up close. So let's look at the numbers here. Yes, they're different than the numbers here. But are they the same square inches? Yes, they are. So we're going to write it is the same. It is the same. Number 11, Mike breaks apart a shape into two smaller shapes. Rick breaks the same shape apart into two different shapes. Explain how you know that the total area of Mike's two shapes is the same as the total area of Rick's two shapes. Well, we know this because the boys each start with what? They start with the same shape.